Today's lesson is 1.7, Basic Matrix Operations. I know we skipped 1.6, but we might come back to 1.6 later on in the year. But me and the other Algebra 2 teachers felt like it was best for us to skip that to save a little bit of time. So we're moving on to 1.7. So you may be asking, what is a matrix? A matrix is a rectangular arrangement of numbers. The dimensions of a matrix with m rows and n columns are m times n, and that's read as m by n. So the dimensions of matrix A below, right here, are 2 by 3, because there's 2 rows and 3 columns. The numbers in the matrix are its elements. We call those numbers inside the matrix elements. A matrix derived from a system of linear equations, each written in standard form with the constant term on the right, is the augmented matrix of the system. For example, the system of equations below can be represented by the given augmented matrix. So we just take all our coefficients, and those coefficients become our elements of our matrix. So the coefficient on the first equation of x is 5. Coefficient for y is 3. Coefficient for z is -2. And as you can see there, they correspond with the elements in our matrix. And then the constants are over here on the right hand side, right here. That's what all our equations equal. Those are our constants. And notice the little statement at the bottom. It says, before you write an augmented matrix, make sure each equation in the system is written in standard form. Include zeros for the coefficients of any missing variables. This determines the order of the constants and coefficients in the augmented matrix. So I believe it was yesterday we talked about standard form. BAX plus BY plus CZ equals D. All my variables are on the left side of the equation. All my constants are on the right hand side. So that's what it means by standard form. And what that second part means is if I have an equation that is 3x plus 2z equals 5, in the matrix it would be 3, 0, 2, 5. I have that 0 there because I don't have a y term. That's what it means when it says include zeros for the coefficients of any missing variables. My y value is missing, so its coefficient would technically be 0. I could rewrite it as 3x plus 0y plus 2z equals 5. So that's what that means right there. This determines the order of the constants and coefficients in the augmented matrix. So let's look at some operations with matrices. Notice I said matrices and not matrices. Matrices is the plural form of matrix. So we don't call multiple matrices matrices, and we don't call one matrix a matrice. It's matrix and matrices. So adding and subtracting matrices. To add or subtract two matrices with the same dimensions, that's very important. With the same dimensions, add or subtract their corresponding elements. So adding matrices is actually pretty easy. First off, they have to be the exact same dimensions. Second off, you just either add or subtract their corresponding elements. So for adding, you can see this example right here. I have A plus E over here. That's because A and E correspond with each other within their own matrix. So you just add A and E, B and F, C and G, D and H. And that gives you your new matrix. Same thing for subtracting. You just do the first matrix minus the second one, subtracting the corresponding elements. If you notice the statement at the bottom, the sum or difference of two matrices with different dimensions is undefined. That's why we can only add or subtract if they have the same dimensions. So let's jump into some examples of adding and subtracting matrices. So letter A, we've got the matrix 2, negative 1, 3, 0, plus the matrix 1, 2, 4, negative 2. So I'm going to do just like the previous slide said to do. I'm going to add corresponding elements in the matrix. So this 2 and this 1 correspond together. So I'm going to do 2 plus 1 in that position in my new matrix. My negative 1 and this 2 correspond with each other. So in this corresponding spot, I'm going to have negative 1 plus 2. Three and 4 correspond, so I'm going to do 3 plus 4 right there. And then 0 and negative 2 correspond, so I'm going to do 0 plus negative 2. So that gives me the new matrix 3, 1, 7, negative 2. That would be my new matrix after adding those two matrices. So like I said, pretty simple. You're just taking the corresponding elements from each matrix, adding them together, and putting them in that corresponding spot in the new matrix. So let me erase this, give myself a little bit of room. Now I've got two 3 by 2 matrices, and I'm subtracting them. So I'm going to do exactly like I did with addition, except I'm subtracting. So 2 and negative 1 are corresponding, so I'm going to do 2 minus negative 1 in that corresponding spot. Now, negative 3 and 2 are corresponding, so I'm going to do negative 3 minus 2. Five and 7 are corresponding, so I'm going to do 5 minus 7. 4 and 8 are corresponding, so 4 minus 8. Negative 2, negative 5 are corresponding, so negative 2 minus negative 5. And then 8 and 6 are corresponding, so 8 minus 6. So I'm just subtracting. I'm doing the left matrix minus the right matrix. So I'm going to put my work up here. So right here, 2 minus negative 1, stay, change, change. 2 negatives make a positive. I get 2 plus 1, which is 3. Negative 3 minus 2 gives me negative 5. 5 minus 7 gives me negative 2. 4 minus 8 gives me negative 4. Stay, change, change again right here. Negative 2 plus 5 gives me 3. And 8 minus 6 gives me 2. So subtracting these two matrices gives me this new matrix right here. 3, negative 5, negative 2, negative 4, 3, 2. Once again, pretty simple. Just doing adding and subtracting multiple times. Now let's look at letter C. Letter C, I have a 2 by 3 matrix, and I'm adding a 2 by 2 matrix with it. If you remember from that first slide, in order to add or subtract matrices, they have to have the exact same dimensions. So in this case, since these two matrices do not have the same exact dimensions, I can say that the sum is undefined. So that's what you would write if you cannot add or subtract the two matrices. Once again, they have to have the exact same dimensions. The first one is 2 by 3. The second one's 2 by 2. They don't have the same dimensions, so the sum is undefined. Pretty simple. Alright, going on to the next slide. Let's talk about scalar multiplication. When working with matrices, a real number is often called a scalar. To multiply a matrix by a scalar, multiply each element in the matrix by the scalar. This process is called scalar multiplication. So it's almost as if you're just distributing your scalar to each element of the matrix. You're just multiplying it. So once again, pretty simple. It's a normal operation we're used to dealing with. It just looks a little bit different with all these matrices. So let's go ahead and jump into some examples. Perform the indicated operations. So I have 2 times this matrix right here. Once again, I just have to multiply each element by that scalar. So I'm doing 2 times 3, 2 times negative 2, 2 times 1, 2 times 5, 2 times 2, and 2 times 0. Just multiplying every element by the scalar. 2 times 3 gives me 6. 2 times negative 2 gives me negative 4. 2 times 1 is 2. 2 times 5 is 10. 2 times 2 is 4. 2 times 0 is 0. So that would be my answer on letter A. Multiplied every element by my scalar, and I got my new matrix. Once again, pretty simple. I feel like it's a pretty easy concept to understand. So let me erase this, give myself a little more room. So now I have a matrix being multiplied by a scalar, and then I've got another matrix being added to it. So using our matrix operations is very similar to our normal operations with just regular numbers. I've got to do my multiplication first before I can do my addition. So I'm going to do my 3 times this matrix first, and then add this matrix to it. So moving up here, I get negative 3 times 5, negative 3 times 0, negative 3 times negative 2, negative 3 times 4, plus this matrix that I still have to account for. So that gives me negative 15, 0, 6, and negative 12. Still accounting for this matrix right here. Alright, so I've done my multiplication, my scalar multiplication. So now I need to do my addition. And I am going to erase because I am completely out of room. So my two matrices were negative 15, 0, 6, negative 12, plus negative 1, 7, 3, and 2. Now, I have to ask myself, can I add these? Once again, to add matrices, you have to have the same exact dimensions. Both of these are 2 by 2 matrices, so I can go ahead and add them. So I get negative 15 plus negative 1, 0 plus 7, 6 plus 3, negative 12 plus 2. That gives me this new matrix right here, negative 16, 7, 9, and negative 10. So I performed all of the indicated operations. Once again, do your multiplication first and then add. It's like our order of operations. Once again, I feel like that's pretty simple to understand. Alright, example 3. This is the last example. Modeling with mathematics. It says a high school district track and field organization used the same standard qualifying times for its 100-meter run district championships in 2 consecutive years. The table below shows the numbers of boys and girls in the 3 class levels who qualified for the district championship in the 2 years. So there's all of our data. It says organize the data using 2 matrices, one for 2015 and one for 2016. Then find and interpret a matrix giving the average number of qualifiers in each class and gender. So it wants me to come up with 2 matrices, one for 2015, one for 2016. So on the next slide, I have those 2 matrices. The left one is for 2015. The left column is for boys. Right column is for girls. Second matrix is for 2016. Left column is boys. Right column is girls. All those numbers came from these tables right here. For my 2015 one, I had my boys column on the left, my girls column on the right. 18, 23, 16, 21, 22, 24. Same thing for this 2016 one. Boys columns were on the left, 16, 25, 12. Girls column was on the right, 15, 18, 18. That's where my numbers came from. Excuse me. So that's the answer to my first part of the problem. It says organize the data using 2 matrices, one for 2015 and one for 2016. I've done that. Now it says then find and interpret a matrix giving the average number of qualifiers in each class and gender. So hopefully you guys still remember how to find the average of something. Say I want to find the average of these 3 test scores. I would add up the test scores and then divide by the number of test scores there are. There's 3, so I'm dividing by 3. Add up all my values, divide by the amount of numbers there are. So it wants me to find the average of all the qualifying times. So I've got my 2 matrices. We're going to call this first matrix right here matrix A. That's what that little A is for. This matrix right here will be called matrix B. We're just giving them a name so we can come up with a little formula. So, to find the average, we need to add up and divide by the number of terms there are. So I'm going to have 1/2 times A plus B. That's going to be my little formula. I'm adding my two matrices, and then I'm technically dividing by 2. That's what multiplying by 1/2 is doing. So I get, I'm going to write a little smaller. One half times A plus B. So that's 1/2 times my first matrix. Plus my second matrix. So I just plugged the two matrices in for A and B in my formula. So we need to use our order of operations. Order of operations tell me to do parentheses first or grouping symbols. So I'm going to add my two matrices first. So I get 1/2 times the matrix 18 plus 16 would give me 34. 21 plus 15 would give me 36. 23 plus 25 would give me 48. 22 plus 18 would give me 40. 16 plus 12 would give me 28. And 24 plus 18 would give me 42. So I added my two matrices first. Now I need to multiply by 1/2. So I'm essentially just dividing each element by 2. So 34 divided by 2 would give me 17. 36 divided by 2, 18. 48 divided by 2, 24. 40 divided by 2 is 20. 28 divided by 2 is 14. It's a bad 4, I apologize. And then 42 divided by 2 would give me 21. So here's my new matrix that is representing the average number of qualifiers in each class and gender. So it says find and interpret the matrix giving the average number of qualifiers in each class and gender. So I've got my matrix. Now I need to go ahead and interpret it. So it's 17, 18, 24, 20, 14, 21. Now I need to interpret this matrix for this given situation. So I could say the average number of qualifiers for the district championship championships in the event were 17 boys and 18 girls in Class 1, 24 boys and 20 girls in Class 2, and 14 boys and 21 girls in Class 3. So I got all that from that matrix. The first row of my matrix is representing the average for Class 1. Once again, the left column is boys, the right column is girls. So that's why I was able to say the average number of qualifiers for the district championships in the event were 17 boys. 17 boys and 18 girls for Class 1. 24 boys and 20 girls for Class 2. 14 boys and 21 girls for Class 3. Those were the averages. So I hope this is all fairly easy for us. If you have any questions, please feel free to email me or message me on Remind, and I'll be happy to get back with you as quickly as I can. Hope you all have a fantastic day, fantastic night, and a fantastic fall break.